Hello and welcome to 5.5, irrigation. And irrigation is a word used to describe how or the different methods there are to water the crops. And on the bottom picture here, you can see there are sprinklers hanging, and those sprinklers hanging are just shooting water out. And then if you look on the top picture, there are these circular patterns, and the reason why they're set up that way is the sprinkler is in the middle, and it basically has an arm, and the arm just goes around in circles. And that is why there is only something growing in that circular pattern and nothing growing over here, because there is no irrigation. So we're going to talk about the different methods of irrigation. We're going to talk about the benefits and the drawbacks of irrigation. This is an important number right here. 70% of the fresh water used by humans is used for irrigation. And if you water too much, interestingly, you can actually waterlog the ground. We're going to talk about that. And finally, we will talk about the efficiency of each of the types of irrigation and the fact that even if you use fresh water, you can actually end up bringing in too much salt into an area, and that can be toxic to plants, which I know sounds crazy. And what an aquifer is and what we are currently doing to them. So irrigation, as we stated, is the largest human use of fresh water. 70% of the fresh water on this planet is used for irrigation. And there are going to be four major types of irrigation. Let's first start off with what is known as furrow irrigation. And that is kind of what this picture is. Furrows are these cuts or these grooves. And if you see in the picture that's in the background, there are grooves cut between the crops. Now this salinization means that, in essence, the ground becomes too salty, because what will happen is, even though it's fresh water, there are tiny bits of salt in there. And when the water evaporates in warm climates, over time, the salt will build up. So they have to be very careful about that. It's reasonably efficient at 66% efficiency, but there is a fair amount, 33% lost to runoff, which is the water that does not sink in, and any water that evaporates, especially where it's warm. Drip irrigation gets the smiley face but the sad face at the same time. It gets the smiley face because it is the absolute most efficient, where the water literally drips out of specialized tubes, goes directly to the roots, 95% efficient. It avoids waterlogging. It will avoid salinization. The only problem is it is very, very, very labor intensive and very, 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 very expensive. So on the large scale, it will not work. For a small-scale farmer, it is much better, saves money, and the water goes directly to the crops. Flood irrigation to me always sounded pretty silly, where you literally flood the ground. But in some cases, it's easy, and this is what they'll do this is how they actually get cranberries out, by flooding the area. But in these cases, this particular crop is flooded. The entire crop is flooded. Unfortunately, it will lead to soil salinization because eventually that water will evaporate. Drawbacks: it can waterlog the soil and ultimately drown the plant. Now the roots at least, do need oxygen. If there's too much water too fast, the roots don't get enough oxygen. 80% efficiency, 20% runoff, pretty decent. And the final type is what those pictures of those circles were: spray irrigation. There are large arms or wheelie pump things like this picture here. The water is sprayed out of nozzles directly into the ground, loses about 25% to evaporation and runoff. It is expensive because there are pumps required to move the water and actually to move these wheels. But a lot of water comes out very, very, very quickly, and it can cover a large amount of area. So farmers will use a mix of these types depending on the crop and the climate. Waterlogging, once again, interesting. If you put too much water in the ground, now they always say plants need water, true. But if there's too much water and the water gets stuck in the air spaces of the roots and it becomes saturated, there actually can be a problem because the roots do need oxygen. The green part focuses on carbon dioxide. That's the whole photosynthesis thing. But the roots do require oxygen, and they need oxygen. It can stunt the growth or kill the crops. And the solution, if you got the money, of course, is drip irrigation or what is known as soil aeration. And this is poking holes in the ground. Some of you may do this, or your parents may have someone do this for your lawn. And what it does is you can either use the machine, which is in the top corner of the diagram, which pulls out those little core things, which you may have seen in your yard, or just simply use spike. Any way to kind of get that water to either drain or evaporate so it does not waterlog. If you are a golfer, they will aerate the greens from time to time. And that just allows the water to get in, to get to where it goes, and any extra to evaporate. Soil salinization, which is what we talked about earlier. This is where too much water over time, the little salts that get deposited as the water evaporates and the transpiration gets pulled out and pulled. That's how plants kind of sweat, if you will, transpiration. And that salinization is the buildup of salt over time. And again, fresh water, you think, oh, fresh water doesn't have any salt, but it does. It has very, very, very bits of dissolved salts. And too much can be toxic. The solution, once again, drip irrigation, soil aeration, or flushing with fresh water, meaning I know that sounds silly, but almost like a distilled kind of water. Again, very, very, very expensive. Or use a freshwater source directly, like a river. Human water use, as we said, huge. 19% is used for industrial, cooling off power plants, cooling off metal manufacturing plants. 11% is what we use, toilets, showers, drinking. And 70% is used for agriculture and watering, and also the drinking of water by animals, livestock. And we'll see that coming up later in the unit. And finally, what is this thing called an aquifer? An aquifer is an area of usable groundwater that is deposited underground for people to use, and you have to pull it out using pumps and various methods. But groundwater is the water that's stored in the ground, and an aquifer is usually deeper, and it's a kind of like a large deposit of water. And you can see here that here's your aquifer right there. And you have to dig fairly deep for it, but if you dig for it deep enough, water will come out of the ground, and that is how we water our large crops. You can get it some water directly from a river, but getting it from an aquifer is much more efficient. And it's replenished by what is called groundwater recharge. That is when it rains and the water will eventually sink all the way into the ground. But of course, we have a problem because humans are pulling the water out of these aquifers way faster than it can sink in and replace them. A soon-to-be problem, which we will also see coming up. Unconfined aquifers will recharge quickly. Those are the ones that are near the surface. That are these guys up here. They're going to replenish themselves quickly or recharge quickly because they're near the surface. A confined aquifer is much deeper. It is much more difficult to get the water down there. The recharge is much, much, much slower. There are a couple of ways that we can deplete our aquifers. We can simply pump the water out of them, and you can see where there are these things called cones of depression. It's where we actually pull too much water out. And if you really look closely, these wells are no longer in the groundwater area. And that could lead to a problem if that happens to be your source of drinking water. So they are called the cone of depression. Another one which you'll see a lot upcoming in this class is what's called a saltwater intrusion. Saltwater intrusion is very interesting. It's where you pull too much water out of a well, and water kind of wants to find the lowest spot. So if it's close to the ocean, the actual ocean water will flow backwards in on that. And then you actually start to pull salt water out of your well, which of course is not good for drinking or watering of crops. And this actual named aquifer will show up. It's askable. It's the Ogallala. Great name. This is the largest aquifer in the United States. It is humongous. It is under multiple states. 1, 2, 3, 4, 5, 6, 7, 8 states. And those 8 states rely very heavily on that aquifer for watering their crops. Well, of course, as we pull water out, it cannot possibly be recharged fast enough. So as, like everything else, a problem. So hopefully irrigation, aquifers, and all of this makes sense. So you'll take a look at this last question or this practice question. Describe how soil salinization occurs, and then propose a solution to prevent the problem. And of course, one disadvantage. These are the kind of questions that you will see. So, see you soon.